Jesus. Okay. Alright, guys. That's about as good as it's gonna get. I'm gonna save the game for now, and then we'll do some space news. Alright. Yeah, I know, Amit, right? Pit stop focus. I have it set to tires. It's been set to tires for a long time, dude. Alright, we'll take a look at the Starship static fire, give you guys an update of what's going on with SLS, but I'm going to take 5 and I'm going to grab some food real quick. Links for space news. Oh, okay. There's some interesting news about Dream Chaser that you guys might appreciate. Okay. But first, as always, I'll put on a public resource. I'll put on a public resource video here, and we'll go from there. Okay. Let me take a look here. See what we can find. I'm gonna switch this up to switch up the title. So, EJ's Space and Rocket Review. You know what? Orbital mechanics. How's the temperature for the room experiment? Well, it's gone up 5 degrees. Gone up 5 degrees in the past 7 hours. You look a little warm. It's gotten pretty hot in here. So, yeah, 4 centigrade. 6, it's going up. Anyway. No, it's not bad. This place holds the, you know, well, I mean, it's gone up, which means this place is holding heat, but it's not holding heat very well. But then again, we did change the internal temperature in here by a couple, so it's not the worst. Not the worst. Anyway, I'll be right back. Guys, enjoy this. Yeah, I'll be back when this is done.
When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the earth was flat, but around 350 BC, Aristotle proved that the earth was round. Later, about 150 AD, Ptolemy presented the geocentric theory, the belief that the earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland presented the heliocentric theory, the belief that the Earth revolves around the sun as it rotates on its axis. This aspect of astronomy evolved into an intricate study of planetary motion, known as orbital mechanics. Today, orbital mechanics is applied to space flight and satellites that orbit the Earth or travel beyond our solar system. In the early 1600s, Johann Kepler, a German mathematician, using the data on planetary observations collected by the Danish scientist Tycho Brahe, developed 3 laws of planetary motion. Kepler's first law states,
all planets move in elliptical orbits with the Sun at one focus and the other focus empty.
applied to Earth satellites, the center of the Earth becomes one focus, with the other focus empty. For circular orbits, the 2 foci coincide. Kepler's second law, the law of areas, states,
the line joining the planet to the Sun sweeps over equal areas in equal time intervals.
when a satellite orbits, the line joining it to the Earth sweeps over equal areas in equal periods of time. If areas 1, 2, and 3 are equal, times 1, 2, and 3 are also equal. Therefore, the speed of the satellite changes depending on its distance from the center of the Earth. Speed is greatest at the point in the orbit closest to the Earth, called perigee, and is slowest at the point farthest from the Earth, called apogee. It is important to note that the orbit followed by a satellite is not dependent on its mass. A large, heavy satellite could be in the same orbit with a small, light one, each sweeping out equal areas in equal periods of time. Kepler's third law, the law of periods, relates the time required for a planet to make one complete trip around the Sun to its mean distance from the Sun.
For any planet, the square of its period of revolution is directly proportional to the cube of its mean distance from the Sun.
Applied to Earth satellites, Kepler's third law explains that the farther a satellite is from the Earth, the longer it will take to complete an orbit, the greater the distance it will travel to complete an orbit, and the slower its average speed will be. Isaac Newton, the father of classical mechanics, laid the groundwork for orbital mechanics. He combined the work of Kepler and others to formulate the law of universal gravitation and the 3 Newtonian laws of motion. While Kepler's laws provided a conceptual model of orbital motion, Newton's laws provided the foundation for the mathematical description of orbits. They explain why a satellite stays in orbit. Newton's law of universal gravitation.
Any 2 objects in the universe, such as the Earth and the Moon, attract each other with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between them.
Stated more simply, the more massive the objects are, or the closer they are, the greater the gravitational pull between them. Newton's first law of motion.
A body in motion will keep moving at the same speed and in the same direction unless acted upon by an external force.
A satellite moves in a curved path around the Earth because the Earth's gravitational pull acts as an external force on it. Newton's second law of motion.
If the sum of the forces acting on an object is not 0, the object will have an acceleration proportional to the magnitude and in the direction of the net force.
Newton's second law states that force equals mass times acceleration. It is this mathematical equation, and the equation for universal gravitation that forms the basis for calculating orbits. Newton's third law of motion explains how a satellite gets into orbit.
For every action, there is an equal and opposite reaction.
If you blow up a balloon and let it go, the balloon is pushed forward by the action of the air rushing out of it. A rocket's exhaust gases are like the air rushing out of the balloon. The following illustrates how a satellite stays in orbit. If a man stands on a mountain and fires a projectile horizontally, gravity will cause the path of the projectile to curve downward and it will strike the Earth. However, if the man fires the projectile fast enough at a specific speed, the curvature of its path due to gravity will match the curvature of the Earth under it. The projectile will then fall around the Earth, becoming an Earth-orbiting satellite. A projectile fired even faster will have a flight path away from the Earth, but gravity will act to slow the projectile down, change its flight path, and pull it back toward Earth. If the projectile's velocity increased enough, a velocity sufficient to escape the Earth's gravitational pull will be reached. This velocity is known as the escape velocity. It is equal to about 7 miles per second at the Earth's surface. The preceding description did not consider atmospheric drag and the Earth's rotation, both of which will affect the trajectory of the projectile. It illustrated the principles governing a satellite's orbit. There are 6 numbers called the orbital elements, which specify the size, shape, and orientation of an orbit in space, as well as the location of the spacecraft in the orbit. Based on an orbit which is an ellipse, the 6 orbital elements are length of the semi-major axis, eccentricity, inclination, right ascension of the ascending node, argument of perigee, time of perigee passage. The major axis of an elliptical orbit is the line joining the perigee and apogee. This line is also referred to as the line of apsides. The first orbital element is the semi-major axis. It is simply 1/2 the major axis. Circular orbits have no apogee or perigee. Therefore, the semi-major axis is simply 1/2 the diameter of the orbit. The semi-major axis is used to define the size of the orbit. From this, the orbital period, or time that it takes for the satellite to complete one orbit, can be calculated. The shape of an orbit is defined by the second orbital element called eccentricity. For all ellipses, the value of eccentricity lies between 0 and 1. The larger the value, the more elliptical the orbit. A spacecraft in Earth orbit with an eccentricity equal to or greater than 1 will escape the Earth's gravitational field. When orienting an orbit in space, a 3-dimensional coordinate system must be defined. The coordinate system commonly used is the geocentric equatorial coordinate system, which has its origin at the Earth's center. This coordinate system is a non-rotating reference system in which a satellite's orbital plane tends to remain fixed relative to the stars while the Earth turns beneath it. The XY plane is the Earth's equatorial plane. The positive x-axis points to the vernal equinox. This is the point where the sun appears to cross the Earth's equator on its way north on the first day of spring each year. The z-axis is along the Earth's spin axis toward the North Pole. Nodes are points in a satellite's orbit which intersect the Earth's equatorial plane. The ascending node is the point at which the spacecraft crosses the equator going from south to north. The descending node is where the spacecraft crosses the equator going from north to south. The line joining the two nodes is called the line of nodes. The orientation of an orbit is determined by three orbital element angles. The right ascension of the ascending node is the angle between the x-axis and the ascending node. It is always measured eastward from the direction away from the vernal equinox in the Earth's equatorial plane. The argument of perigee is the angle between the ascending node and the point of perigee. It is measured in the orbital plane in the direction of spacecraft motion. Inclination is the angle between the equatorial plane and the orbital plane. A satellite which has an eastward velocity component at the ascending node has an orbital inclination lying between 0 and 90 degrees. Such an orbit is called a prograde orbit. A satellite which moves due north at the ascending node is in a polar orbit. Polar orbits have an orbital inclination of exactly 90 degrees. A satellite with a westward velocity component at the ascending node is in a retrograde orbit and has an orbital inclination between 90 and 180 degrees. The 5 orbital elements explained thus far describe the size, shape, and orientation of the orbit in space. The final element is a time value used to locate the satellite in its orbit. A satellite moves in a very predictable manner. It stays on schedule. Thus, if the time at which a satellite passes a particular point is known, the time when it will pass any other point can be determined. The particular point chosen is perigee, and the time of perigee passage is the last of the 6 orbital elements. The 6 orbital elements depict a spacecraft's orbit in non-rotating coordinates. To visualize an orbit relative to the rotating Earth, a projection traces the spacecraft's position on the Earth's surface. The projected path is called the ground track. As a satellite orbits the Earth, the ground track shifts westward. There are 2 causes for this. First, the primary contributor is the Earth's rotation toward the east under the orbital plane. Second, because the Earth is not a uniform sphere and bulges at the equator, its gravity is greatest at the equator. This causes the orbital plane to rotate slowly around the Earth's polar axis in a motion called precession. Precession is toward the west for prograde orbits and toward the east for retrograde orbits. For low Earth orbits such as those of the Space Shuttle at 150 miles altitude, the westward shift of the ground track due to the Earth's rotation is about 22.5 degrees, while the shift due to precession is only about a half degree. The inclination of a satellite orbit determines the north and south latitude limits of its ground track. The minimum orbital inclination is equal to the latitude of the launch site and is achieved by launching due east. For example, if a satellite is launched due east out of the Kennedy Space Center, which is located at 28.5 degrees north latitude, its orbital inclination will be 28.5 degrees, and the limits of its ground track will vary between 28.5 degrees north latitude and 28.5 degrees south latitude. If launch azimuth or direction of flight at launch, measured eastward from due north, is increased from due east, the orbital inclination angle increases as well as the maximum latitude of the north-south ground track. Therefore, the latitude limits of the ground track equal the new launch inclination. Similarly, if launch azimuth is decreased from due east, orbital inclination once again increases, as well as the latitude limits of the ground track. The maximum practical inclination from a Kennedy Space Center launch is 57 degrees. This limit is imposed for safety considerations in order to keep the spacecraft and its booster system from flying over land masses during the ascent phase. To obtain an orbit with an inclination greater than 57 degrees, the spacecraft is launched from Vandenberg Air Force Base in California. Vandenberg offers the opportunity for southerly launches with orbit inclinations between approximately 70 degrees prograde through 138 degrees retrograde. A significant advantage of launching from Vandenberg is the capability to economically achieve polar orbits with ground tracks covering all latitudes, from the North Pole to the South Pole. The Earth is constantly turning, and all points on its surface have an eastward velocity, with the greatest velocity occurring at the equator. The farther the launch site is from the equator, or as launch azimuth is increased or decreased from due east, less of the Earth's rotational velocity will be imparted to the launch vehicle. This requires more fuel to get into orbit, or payload weight will have to be decreased. Launches due east from a position on or near the equator, such as the Kourou launch site in French Guiana, used by the European Space Agency, acquire the advantage of a free velocity gain of about 1,500 feet per second. This compares to the approximate 1,300 feet per second gain available at the further north latitude of the Kennedy Space Center. Launching from an equatorial site offers a significant advantage in payload weight capability and minimizes the amount of fuel needed to achieve an equatorial orbit. Since many satellites operate in equatorial orbits, these are important considerations. Spacecraft are launched within a specified time interval called the launch window. Some of the factors affecting the launch window are launch and orbit lighting conditions, sun angles, payload orbit requirements, rendezvous phasing if a rendezvous is planned, tracking and communication requirements, and collision avoidance with other orbiting objects, to name a few. One of the factors defining the launch window for the Space Shuttle is launch lighting conditions, which can be illustrated by plotting time versus day of year. On this plot, we see daylight and darkness at the launch site. The longer daylight hours occur in the middle of the year, summertime. If daylight conditions are required for a convenient emergency landing site for the Space Shuttle, the launch window would now look like this. During the winter months, the available launch window for lighting conditions alone can be as little as 3 hours per day. When combined with the many other launch factors, the launch window becomes even more constrained. The choice of a particular launch vehicle for a mission depends upon the weight and size of the payload and the desired orbit. Expendable rockets used to place spacecraft in orbit usually consist of several stages that may incorporate both solid and liquid propellants for propulsion. When the fuel in each stage is depleted, the spent stage is jettisoned. Staging offers the advantage of discarding weight when it is no longer needed. The Space Shuttle is a two-stage system. At liftoff, the 2 solid rocket boosters and 3 Space Shuttle main engines are all producing thrust.
Make sure
After
to
approximately
stage
2
these
minutes of
nuts.
flight, at an altitude of 25 miles, the fuel in the solid rocket boosters is depleted and they are jettisoned. The 3 main engines, fueled by liquid oxygen and liquid hydrogen carried in the external tank, Continue to burn for several minutes until the shuttle reaches its cutoff velocity. At this time, the main engines are shut down and the external tank is jettisoned. 2 additional burns using the orbiter's maneuvering system, referred to as ohms, are required
guys,
to
I'm
place
back.
the orbiter in its final orbit.
You guys want to finish
The
this up?
ohms 1 burn occurs about 2 minutes
Or do we
after
want to get into
the
it?
engine
Up to you
shutdown
guys, dude.
and establishes the orbital apogee point. The ohms 2 burn takes place approximately 30
Dunker.
minutes later and circularizes the orbit.
I miss my spaceship.
Once satellites are launched and put into orbit, it is often necessary to change the orbit with an on-orbit burn. The common term used in describing on-orbit burns or engine firings is delta V. Delta V is the incremental change in spacecraft velocity
What's that, baby?
measured in feet per second resulting from the burn. The amount of fuel used during a burn depends on the desired delta V change and the mass of the spacecraft.
Cool.
Because the amount of fuel carried is limited, fuel consumption is one of the primary considerations in spacecraft mission planning and is critical to orbit lifetime.
Hey, weather guy.
On orbit, a spacecraft can thrust in any direction. Burns along the flight path, forward and backward, are the most common. A unique feature of any orbital burn is that if no other burns occur, the spacecraft will later always pass again through the point of burn. Forward burns increase the spacecraft's
you have a link
velocity
for the video?
and are
Yeah.
known as
Yeah.
posigrade
Sure.
burns.
I'll look at the video right now.
With posigrade burns, the flight path of the vehicle will be raised at all points except the burn point. Burns opposite the direction of flight, which slow the spacecraft down, are called retrograde burns. For retrograde burns, the orbit will be lowered at all points except the burn point. The greater the delta V, the greater the difference between the pre-burn and post-burn orbits. Burns can be combined into maneuver sequences to change orbit size, shape, or orientation. One of the most common maneuver sequences is made up of 2 burns and is used to accomplish an orbit transfer between 2 circular orbits
See, I
in
got the
the
guitar by
same
my side.
orbital plane.
I don't have it set up here yet, Alien.
The
but
most
soon.
energy
Soon,
efficient transfer between 2 orbits of this type is the Hohmann transfer.
soon. But I am Mr. Thoo.
The Hohmann transfer is actually 1/2 of an elliptical orbit with its perigee in one of the orbits and its apogee in the other.
Weather
The
guy.
burns occur at the perigee and apogee of the transfer orbit.
Weather guy. You think Earl's gonna
The
make
use of
landfall?
the Hohmann transfer minimizes the delta V required,
That's gonna miss.
thus having the advantage
Can't
of
go fit.
using minimum fuel. The disadvantage of the Hohmann transfer is that it takes longer than most other transfers. The type of the transfer sequence depends on the mission and the amount of fuel available. For example, a space rescue where time is critical might use a fast transfer, while a routine satellite deployment where fuel saved for later use is important would most likely use a Hohmann transfer.
Stay in the Atlantic.
The burns discussed so far have all been maneuvers in the original orbital plane and do not affect orbit inclination or node position. There are situations
What?
which require an orbital plane change, such as setting up a rendezvous or placing a
I just want to point out that this footage is just kind of placed in there like it's no big deal. That is literally a man wrestling a satellite in space. I'm just want to put it out there. It's just like, oh, yeah, this is just more footage. That is a man with a space jetpack wrestling a satellite in space. I'm just put it out there. They just kind of show this footage in this video, like, yeah. Oh yeah, they do that.
placing a satellite in
All
an
right.
equatorial orbit. To change the inclination, the thrust vector
Just
must
come
be
here.
directed at an angle to the
Yeah, but he
orbital
lost.
plane.
Yeah, it's
A
okay.
thrust with a
He had a
component
shuttle
that is
behind him. It had
perpendicular to the
reinforcements.
orbital plane at either the ascending or descending node will rotate the orbital plane about the line
Yeah.
of nodes.
Aqualex, you weren't here for this part, dude. It's when you were off doing your own thing,
Go
dude.
and throttle up.
I've talked to that guy. I shook that guy's hand. Yeah, that's George Nelson. Yeah, I've shook his hand. I asked him about it, like firsthand. He was like, dude, I couldn't. He didn't say it like this. He essentially couldn't get the grapple hook to work exactly right. He couldn't get the latching end effector on the end of the MMU to latch the satellite because it was moving. It had a slight rotation to it. Yeah, he couldn't get it. He tried. He tried to basically, like, when it came around, hit the grapple and kind of then, go with the thing, but it didn't work. He ended up having to back off with the jetpack, and they went and grappled it with the arm, which is actually pretty cool. Yeah, I've talked to that guy at Space Fest 2019, and I was, like, shocked that nobody... He was just sitting, like, there was a bunch of booths for a bunch of different astronauts, so, like, Charlie Duke was there, and the line for Charlie Duke was unbelievable. George Nelson just sitting there just going... And I'm like, you're George Nelson. Why don't you have a line out the door? You wrestled a satellite in space. He's like, I don't know. I'm like, okay. Joseph, 24-month resub. Thanks, buddy. Yeah, Astro. I've met that guy.
Example,
Not that
a
guy.
space rescue where time is critical might use
Actually,
a
that might still be Solar Maximum.
fast
That might be
transfer,
him too.
while a routine satellite
Oh yeah,
deployment,
Alexi was
where
like, yeah, I
fuel
did do
saved
that.
for
I'm like,
later
you
use is
wrestled a
important,
satellite in
would
space.
most likely
That's pretty
use
cool.
a Hohmann transfer.
Oh, okay. Well, the guy, yeah, we'll do. That would just be normal once the shuttle program fully ramps up. Oh yeah, no, that's not even getting close. Yeah, okay, cool. Yeah. Freaking nuts, dude.
The inclination,
Straight up.
the thrust vector must be directed.
Straight up wrestling a satellite. Right? Right there, dude. Yeah, see? You can see the satellite has a slight roll to it. Look at that. Isn't that nuts? You could really see it if we fast forward. See that? That's crazy, man. Can you believe that?
Satellite orbital planes and altitudes are determined by their design.
That mission was a little bit different. That satellite got... So you guys see that satellite? Get this. This is the potential that the shuttle has, okay? This is the potential. And they started to utilize the potential, and they never got to it. That satellite was launched from another rocket. Another rocket put that thing into space. The space shuttle went up there, grabbed it because it wasn't working, brought it back down, and then gave it back to the person that launched it into space on another rocket. And then they fixed it and they launched it again. It's kind of like with Hoot Gibson at the airport. Few people know him by sight. Yeah, exactly, Neuro, right? Unbelievable. If you know, then you know. Yeah, they pulled that. They grabbed that satellite out of orbit with the shuttle and brought it back down to fix it. It's a gnarly freaking mission. How long do you think until we have aged whiskey in space? It's probably happening sooner rather than later. Lather? Okay. But yeah, we can get more into orbit stuff with that later. But Jason, you're here. I wanted to start off today's space news. First of all, hi, welcome. I wanted to start off today's space news with a little bit on the shuttle ground service equipment. Jason, you had a question about the rotating service structure and what it does, right? Cheaper to build a new satellite. It's cheaper to build these nuts. Got them. I'm amazed that it works so well. Yeah, it's pretty crazy. All right, so I had a couple of questions about the shuttle RSS. Let me take a look, see if we can find a good picture of it. Okay, so I'm going to use this picture. So check this out. Jason, you see this thing right here? That's the rotating service structure. The rotating service structure was a structure that was used to load payload in the vertical configuration into a shuttle that was already on the pad. No, the astronauts don't enter up here. There's a bridge crane up here. That's what it's called. So shuttle rotating service structure. There's a bridge crane up there. They actually don't enter that way. Let me find a better picture. This will work. So they don't actually enter through there. There's a crane up there, and that crane can move out a little ways, right? And then when the service structure, yep, there it goes. When the service structure isn't in the rotated position up to the shuttle, they'll load it up with a payload, see? Now, people don't actually get into the shuttle using the service structure. People got into the shuttle using the crew access arm. The crew access arm, I'll show you in a second. It's right there. It is a separate piece of equipment. Now, that's pretty neat. Basically, what this thing does is establish a clean room environment around the shuttle's payload bay. When it's in the open position, like how it is right now, they could pick up stuff and put it inside of a gigantic clean room right here. And then they would rotate it into position, open up the shuttle payload bay doors. The doors, the outside doors from the rotating service structure, those ones right there, actually latched on to the space shuttle's doors and then opened them up, so they could power the doors open. And then when they did that, the doors basically opened up into the rotating service structure payload changeout room, or PCR for short. And then they would just basically wheel the satellite right in. They would just roll it right in the vertical configuration, just whoop, right in, and then you're good to go. Yep, there it is. We move out of the way. See? You can see the brackets that they use to attach to the doors on the space shuttle, and then you just open it right up. And then there's a couple of gantries right here. Yeah, I'd like to keep in mind that this is on, that's on basically like a, it's on about a 200-foot kingpin right there, the whole structure. And that structure is about as big as a gymnasium, and it moves. Yeah. How heavy was the RSS? I don't know. Both of them are gone. There was two of them. They both got scrapped. The last we saw of the rotating service structure, believe it or not, is actually, I have that picture. It's right there. That was the last of it. SpaceX got rid of it in 2017. Yeah, that kind of hurts to see. Now I'm sad. Yeah, see the kingpin right there? The gigantic hinge. The whole thing rotates into position, and like I said, you can see where the whole payload changeout room. Like I said, it's about a gymnasium. It's the size of a gym, and it's about 50 feet tall. So it's about the surface area of a gymnasium, like a basketball court, but 5 stories tall. The service structure was huge. I mean, I get why they axed it, but it still stings. Yeah, what the hell is SpaceX gonna do with it, to be honest with you? Yep, SpaceX scrapped it. They had to scrap it piece by piece and then by the time I think 2018 rolled around, it wasn't there no more. It wasn't there no more. It looks like that now. The cool thing is that the kingpin is still there. See? That's the original kingpin from the rotating service structure. I don't know why they kept it, but they did. See? You can even see the tracks for where the hinges were. Saved it for Starship. Right. Yep. Yeah, sure. Of course they did. Anyway, yeah, a little bit on the rotating service structure. Pretty cool piece of equipment. Maybe it was too tied into the fixed service structure. Yeah, possibly. I mean, I'm sure there was a reason. More likely, I think it was more tied into the ground than anything. And it ain't in the way, so just leave it there, right? Like, what is it? Who cares? I mean, you know how much force is put on that damn kingpin to rotate a structure as big as I just said? Like, I'll bet you the pilings for that kingpin probably go down a good ways. So yeah, why even bother? I mean, if that's what you were getting at, then yeah, absolutely, yeah. It's why bother? Screw that. Waste of time that is. Transferring all the rest of the space links here. Probably saved to try and maintain some of the history of the site. I don't think SpaceX gives two fricks about that, dude, to be honest with you. All right. Let me take a look, see if we can just organize this stuff up. I'm going to try to do everything that isn't Starship, because that's the hot news right now. Starship did just do a static fire, and it was pretty freaking cool, actually. Yeah, it was pretty cool, to say the least. Literally hot news. Yeah, get it? Here. You know what? We could show it. I think showing it multiple times is probably a good idea. So here, take a look. Headphone users, potentially. Yeah, exactly, Guy. Yep. Thought I was trying to quote Sam Rockwell. Nice. To quote Mike, different problems for big rockets recently. SLS no fire, Starship too much fire. Yeah, Starship just need to give SLS some fire anyway. Wow.
There you have it.
There you have it. 6-engine static fire from Starship. One more time.
There you have it. Looked like a great static fire from Starship.
It was awesome. Dude, it sent it a little bit too hard. It sent it a little bit too hard, to be honest with you, because, yep. It sent it a little bit too hard. Burnt off some of the grass there. Too much evil. Yeah, that fire got to be pretty bad there for a second. Yeah, it's probably a little broken down there. Yeah. You guys want to see it again here? Where's the good stuff? This was actually pretty recent. It's just a second ago. About an hour, actually. Yeah, that's a lot of fire. Here we go. Oh, man, that's cool. Just a prescribed burn. Burn off all the underbrush. Yep.
There you have it.
Oh, that was so legit, dude. So it looked to be all 6 engines. 5-second burn duration. But yeah, that's all the plumbing. All the plumbing on that sucker. There you have it. It's like 7+. Let me see. And as always, before we do this footage is coming from our buddies over at NASA Spaceflight. Go over there, subscribe, buy a mug or something, do something. T-shirts, they have cool T-shirts. One hop. Make sure you do that, guys. Go over and support them. If you support them over there, that supports me over here inadvertently, because they literally, I can just watch all their footage, which is just all right. I don't know. I still don't know why they let me do that, but hey, whatever. Go over there, go watch. Give them a sub to YouTube at least, please. Yeah, 7 to 8 seconds. Interesting. So, couple of things here. Let me see that in slow motion. Let's see that in an instant replay. Okay. Sequenced ignition. Sequenced ignition. It looks like SpaceX fired 2, 2, and 2. That was definitely 6 engines. I mean, so there's one ignition. There's a second ignition. There's the third ignition. Maybe. Nah, maybe. I can't tell. Let's look over here. One ignition. 2 ignition right there. 3 ignition right there. Yeah. They fired. Yeah. Yeah, 3 by 2. So they fired one sea level, 1 vacuum, 2 sea level, 2 vacuum, 3 sea level, 3 vacuum. That's a guess, though. I'm not sure. Let me see it one more time, just because it's awesome. Wow, that's absurd. That's what I would do, Tessa. Yeah, I mean, not that I'm an expert on this by any means. How did it not take off? Hold down points, boy. Hold down points, boy. Now it looks sped up. I want to see it again. Hold on. Can I do it again? Dude, you can just tell how violent it is. Watch, like, you'll get an engine ignition, and then you get another ignition, and then by the third ignition, the sound reaches the vibrations, and the sound reach the camera. Look at how much this camera shakes on the left. See that? See that camera? The camera's like, "Duh!" Crazy, right? If they start in sequence 2, they shut off in sequence 2. No, you can cut all of them at the same time.
There you have it. Looked like a great static fire from Starship 24.
And now, if we go up to the live footage, give it a second. There you
An
have
useful
it.
tool when done in a very controlled
Yes!
manner in terms
Yes, you
of
buddy.
keeping up the ecosystem and things like that. But this was not one of those prescribed burns. So, okay, positive spin. It can't be happening when you're trying to test a rocket engine. You know what I mean? Let's not pull any punches on that.
Yeah. TJ Clooney, thank you for your support. You're regular. We see you all the time, and that's very much appreciated. Tom Dalton says the lids
Fine.
on some of the dumpsters are plastic.
Ah,
That would be very helpful, wouldn't it?
And it looks like Starship did lose some tiles there. Yeah, they definitely lost some tiles. That's countering your sarcastic comment.
that you open up, but you don't want to touch it except with 2 fingers, and then you throw your household garbage in. Like that's not the dumpster I think this is. I think it's one of those big open top containerized dumpsters.
I love the explanation of the feeling you have when
What's
you throw
that?
something in that came.
What's that coming from Zach? Almost 30 or so missing tiles on Ship 24 after a 6-engine static fire test that lasted 8 seconds. Yikes. Yeah, I guess that some of the dumpsters that are around did actually light the thing on fire. Anyway, that's the big stuff. I'll keep that up. We'll keep that going up in the background there, and we'll get into the rest of the stuff. So, if Starship loses 1 tile, this could be a reason to explode in re-entry. It's possible, Dennis. Yeah, it's possible. Let's see. The vibration shouldn't be as bad with full stack. Yeah, but it's something. I mean, MotoKid, I'm going to go ahead. Like, okay. I'm not an expert on this, dude. I'm not an expert on this, but I'm going to go out on a limb and say that if it can't handle 6 engines at close range like that, it's not going to handle 33 engines 70 meters below it. You know, how can I be sure about that? I don't know. Call it a gut feeling. But then again, sound isn't necessarily reverberating off the ground there. But I'd be really interested to go pick SpaceX's brain to see if those tiles are coming off from vibrations, or are they coming off because of sound reverberations? Those are different. Are the vibrations amplified by being bolted down to the ground? No, if anything, bolting it to the ground attenuates them, Torg. I'm pretty sure. It dampens them out. And SpaceX uses a garden hose for sound suppression. Oh. Ugh. But yeah, I don't know. I'll tell you this though, like I'm pretty sure 33 out of the thousands of tiles that has, or 30 tiles, is actually really not bad. That's pretty damn good. Were these suborbital stands even designed for more than 3 engine ignitions? No free napkins? I would say no. I would say no. So anyway, next bit of news. We'll get back more into that later. Greg Scott did more flyby. Greg Scott is an independent photographer here. He photographs from Marcus' house. I didn't know that. That's pretty cool. Greggy. All right. So what did he take a picture of? Exciting day at Port Wed when we spotted what appears to be the Starliner capsule in an old Dragon mock-up doing water testing. Then I spotted the current Dragon capsule doing testing in another part of the port a little bit later. What do you think, Starliner or maybe Orion? Well, let's take a look. Yeah, that's Starliner. Yeah, absolutely Starliner. The docking port on the top. Yeah. Interesting. Wow, a Dragon 1 mock-up. Look at that thing. Yeah, that's definitely Starliner. The parachute mortars, the way the docking port is at the front and the RCS. Orion's RCS doesn't look exactly like that. Hey, weather guy, in other news, I got a new job. I'll be a data engineer for the greater weather industry, so if you ever need weather data, I'm your guy. Yeah, I know, it says it in your name. No, seriously, that's cool, man. All right. All right, so, yeah, there you go. Also, cool crane. Whoa, cool crane. Yeah, interesting. All right. Oh, Dragon 2. Cool. That's pretty sweet. Furred. Anyway, this is Port Wed, he said. I'm not 100% sure where this is, guys. SpaceX, tweet. SpaceX, tweet. Starship testing site or skate park? I'll let you decide. Seriously, though, that 10 stair looks pretty sweet. This is the middle turning basin in Port Canaveral to the left of where rocket ship docks. Yep, I got it. That's pretty awesome, dude. So we got a confirmation that it was a 6-engine static fire. Dude. Dude, the rumble. But just by the rumble, I could have told you that, man. Like, this beast is a beast. I will just be retweeting that. Excuse me. Elfish, nice. You had to deal with that with helicopters when they came in and touched down. We had a whole F1 team style tie down routine just to lock it down to the deck in case it got just the wrong frequency going up and started to reverberate. Cool. And no lost heat shield bits. They did lose a couple of tiles, man, but not a lot. Seriously. But actually, some interesting things to see here from this picture. Let's take a look. So this was obviously right at ignition. And those tiles, 1, 2, 3, 4, 5, 6. There's already some tiles falling off. That is, without a doubt, from the overpressure event. Yeah, that's from the overpressure. So that would mean that is that's sound. Sound reverberation would do that. Is the camera that took this still with it? I don't know, dude. I really don't know. That's a good question. This is just condensation coming off the vehicle. Ignition overpressure knocking tiles off. Yeah, well, Bill, that's how I know it's not vibrations. If these tiles are all off right at ignition, you know that that's from sound reverberation. They need a better sound suppressor. But then again, you ain't going to be firing first stages this close to the ground at any point during Starship's operation. So, I mean, I don't know. I guess that behavior needs to be understood, though. But either way, yeah, SDS1, yeah, exactly. Yeah, they had that same problem. The SRBs overperformed. They didn't give the shuttle enough of a pad deluge, and the SRBs were so loud it shook tiles off the back of Columbia. True story. What about landing on the moon and Mars? Well, the moon, I would be more worried about kicking up dust on the moon than anything. And on Mars, also kicking up dust more than anything. And there's no sound on the moon, and there's very little sound on Mars because you need air to carry sound. That's why in space no one can hear you fart. It's true. So, yeah, I wouldn't worry about it. It's probably not as much Tomas, but once again, as always, it is more about understanding the vehicle's behavior, understanding what it's doing. I mean, it's true. Either way, though, good confirmation from SpaceX there. I forgot about that stuff, that the Moon Starship doesn't have tiles. All good. Tried to steer you back. Anyway, that's a confirmed tweet from SpaceX. So this is coming from Periel. Yule's rocket ship was in Port Canaveral yesterday, offloading maybe a side booster? Question. Next to it was some sort of water testing for the top end of something. Oh, yeah. Okay. Thomas, this gives a little better of it. Oh. CBC with nice new spray-on foam installation. Look at how not orange it is. Yeah, it's not. Well, Rocket Guy, it's obviously because it's not ripe. All right, it's not ripe. No, it's not ripe. It has some way to go. You got to pick it when it's ripe, so it'll launch correctly. Sunlight will change that. Well, yeah, it does with most vegetables, man. Hello, and fruit. I thought you were supposed to be a rocket guy. Jeez. Doesn't have the juice yet. I will slap you into next week. It's just basic rocket science. Yeah, so rocket continuously learning. So rocket guy's right. So the lighter color from the foam insulation means that this booster was it's freshly manufactured. The longer it stays out in the sun, SLS, the more orange it'll get. Yeah, it's just how the foam reacts to the sun. But the foam is actually a really, 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 really washed out light orange when it's first applied, when it comes out of the factory. It's not ripe enough. Perfect time to show the daily SLS picture. I mean, not gonna not show the... How did that get in there? Fudge. How did that get in there? Hello. White corn, that's a thing you know. You know what? You know what, Meg? It's not. Okay? What was that? Just somebody that I used to know. Okay, so, well... Nice. While we're on the subject of SLS, the tail service mast umbilical was, actually, you know what? I'll just show you the live press room footage. Maybe if we go back over here a little ways. Yeah, see, they erected an enclosure around the hydrogen tail service mast umbilical. Right there. There is a little impromptu clean room there. And inside of that clean room, they bus. Lock the taskbar. Lock the taskbar. That's a Clash song, right? Yeah, it was a J2X. That belongs in your Constellation or Ares folder. I know. I can wish. I can wish. Anyway, so they erected an enclosure around it. They're switching out the seal on the hydrogen line, and then they're going to inspect the other seal. They're going to inspect the one that got pinched somehow, and they're going to replace it, and then they're going to take that other seal and they're going to analyze that one. They're going to use a Michelin model XGV 75R14 with flame spectrum analyzation. Tire? Anyway. So, they're going to take it, they're going to figure out why the seal got pinched, and in the meantime, they're going to replace the seal. So, NASA is trying to do a tanking test with that new seal on the 17th, just to fill and drain on SLS to make sure the seal is working correctly, and in the meantime, they're going to figure out why the other one went bad. Simultaneously, NASA has also gone to the range to try and presented them with a package and contingency plan for keeping SLS on the pad and recertifying its flight termination system batteries on the core stage. Was that your smart Texas voice? It's from my cousin Vinny. Yep, there's a reason we do static fires much better to break things on the ground than en route to orbit. Good call. Ugh. Pay receipts. Yeah, it's one of my favorite movies. So, NASA is, long story short, guys, NASA is avoiding trying to roll that thing back to the VAB at all costs. They really, really do not want a rollback. The reason why they don't want a rollback is because, excuse me. The reason why they don't want to roll back is because that puts unneeded stress on the vehicle. It does fatigue the vehicle. I'm trying to tell you, SLS gets tired. No, the crawler transporter and moving it back to the VAB is going to induce vibrations on the vehicle. Now, don't get me wrong. they can roll back to the VAB if they absolutely need to. They're just going to try to find a contingency plan that makes it so they don't absolutely have to do that. Remember, this is a test flight, and it's very important to get good baseline data. It's not that rolling it back to the VAB and then rolling it back again is going to mean that it'll break now. No. It has nothing to do with that. It's more about making sure that this is a good bench test of the vehicle. And you always want a test flight to be as much of a mirror of an operational mission as you possibly can, right? So, if you picture kind of an ideal SLS mission in your mind, right? Say in the future, it's 2026, Artemis 3 rolls out. All right, our Artemis 3 is in the VAB. They build the rocket in the VAB, they roll it out to the pad, put it down on the pad, hook up all the connections, do a week worth of checkouts. Astronauts go to the pad the day of launch, they fuel it up, astronauts go in, they launch it, and then you're good. That's literally, in the most ideal scenario, that is one roll to the pad. NASA wants to try to get as close to that as possible. Now, obviously, you're never going to get that close with this core stage, because they green run. This core stage has been used. It's been fired before. They green runned it twice. One time unsuccessful, one time successfully. Then they took it apart. Then they sent it. Well, not took it apart. Well, they took it apart. They refurbished it. Then they sent it to KSC. Then they stacked it. And then it's gone out to the pad multiple times now. 2 wet dress rehearsals and the launch attempts. Or 2 sets of wet dress rehearsals and a launch attempt. It's not that all this is going to make the rocket more likely to fail. It's really about getting good baseline data. And don't get me wrong, like I said, NASA could roll back to the VAB if they really want to. But after the test flight, all of this potential changes to the vehicle from rolling it back and forth is going to have to be taken into account and applied to the flight data, right? And that's going to take longer to analyze. It's going to take longer to figure that out. So they're trying to avoid basically putting the vehicle into an unwanted failure mode, or just any type of mode that's not what's ideal for a bench test. They want to get good telemetry from it. It's that simple. Yeah, they really, 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 really don't want to roll that thing back. Now, like I said, I'll say this once, I'll say it again, guys. They could roll it back if they really need to. They don't want to, though. It's right now that contingency, it's contingent on what the range says. Once again, NASA submitted them a contingency package, as John Blevins put it, basically saying, look, I know you need these batteries to be recertified. I can prove to you that they're going to be good on there for another month. NASA isn't worried about SRB expiration either. They're not worried about the SRBs not working. And they said, Northrop Grumman says they're confident that the SRBs can stay on the pad for a month, more or less. So they're going to target that tanking test on the 17th, and then pending what the range says, NASA has 2 windows targeted for potential Artemis 1 launches. One is on the 23rd of September, which is a Friday, and then the 27th of September, which is a Tuesday. Targeting both of those. And once again, no times had really been given. It's just those 2 dates. They said something about the 23rd, though. They don't necessarily want to go on the 23rd because there will be a range conflict. But it won't be a range conflict at the launch site. It'll be a range conflict with the Deep Space Network. Because DART, NASA's Double Asteroid Redirect mission, is going to impact Didymos, an asteroid, and see if it can redirect its course by literally crashing into it. That's going to happen on the 23rd, so the Deep Space Network will be used. Why? What do you mean by the Deep Space Network being used? Well, if DART's over there and SLS is going to the moon over there, the radio antenna can't point in 2 different directions at once. There you go. Do they have multiple antennas to do this? Yes, absolutely. But you need the big dishes to communicate with Orion. Didymos deserves it. It's Didymos and Dimorphos, if you really want to know. So NASA isn't just hitting an asteroid up in space. What they're trying to do is hit an asteroid that's orbiting around another asteroid. There's Didymos and Dimorphos. One is orbiting around the other, and they're going to try to hit the orbiting asteroid and see if it changes its orbit around Didymos. True story. They need omnidirectional dishes. If you want to make like a 150-meter phased array for NASA, please do that. The DSN is ground antennas. There's also TDRS, which can be used to communicate with something else, right? I mean, Signer, no, not really. You can't use TDRS for this. The problem is that the tracking data and relay satellites might be able to communicate with DART, but they're not pointed in the right direction. TDRS is pointing towards Earth, remember? DSN is pointing away from Earth because they're pointing up. See what I mean? If you're getting beyond high Earth orbit, yeah, TDRS is kind of useless. Q or E can solve that. Found the Kerbal player. So, yeah, NASA's working on some contingencies, guys, and, you know, they have daily press conferences, basically, and I've been here since this morning. How long has DART been up in space? We watched it launch earlier this year already. Yeah. So, yeah, you know, it's going to take a month, but actually the guys at NASA said this, like, look, people remember failures, but they don't remember scrubs. We can be confident that this rocket, when we are ready to fly it, will work. Commitment from NASA this morning, which is pretty cool. I've seen an article about Artemis highlighting the need for better communications and monitoring beyond low Earth orbit. Okay. Imagine a miss. Yeah, right? I mean, yeah, can't TDRS still technically do stored and forward relaying? Could point it at Orion for getting data, then point it at Earth and relay it back to the ground. TDRS doesn't process data, Signer. It doesn't process any data. It just forwards a signal. You bounce signals off of TDRS. So it's just a dish. It's just a parabolic antenna, no transmitter. You just bounce signals off of it. That's, yeah, in satellite terms, that's literally what a relay does. It just takes the signal and shoots it in a different direction. Yeah, TDRS does not process any data. It just bounces it. Yep. So, yeah, SLS is shaping up. Starship is doing amazing things. Yeah, pretty good stuff. Let's see what else we got. Speaking of Starship, Harry Stranger got us more pictures of the Space Coast, giving us a fresh look at Complex 39A, Roberts Road, and Hangar M. Looks like the tower is almost up. There's the new Starship production facility at Roberts Road. That's been making some pretty good progress. Yeah, they got a lot of that paved up. Look at that thing. Man, is that building going up quick. The last time we did a KSC flyover, or we watched any of NSF's KSC flyover videos, this thing had no concrete foundation. Crazy. And then there's Hangar M, SpaceX's Hangar M. They're building the orbital launch mount for Starship for this pad. You can see the 6 posts are right there. They're building that in Hangar M. So that's why they have all this subassembly. SpaceX is using that to build stuff in there. Starship GSE is going up quick. Rev, it's kind of alarming how fast those guys go, you know? But yeah, anyway, this is coming from Jeff Faust. What's Jeff up to? Iridium announced this morning that it will launch 5 of its 6 remaining spare satellites on a Falcon 9 rideshare mission in mid-2023 from Vandenberg. Iridium said in a recent earnings call it had plans to launch those satellites, but didn't disclose the provider at the time. Oh, cool. Iridium's going to launch more in Falcon. I thought we were done with that. A lot of early... So, what does Iridium do? Iridium is satellite communications, particularly like sat phones. Like, you guys ever see in the movies, they have that sat phone with the antenna that's like hinged on the side that you can fold up? Those Iridium was one of the first low Earth orbit constellations back in the 90s. And about 5 years ago, that's really weird saying that. About 5 years ago, Matt Desch, the CEO of Iridium, wanted to replace his constellation, and he used Falcon 9 to do it. I think they launched 9 Iridium missions out of Vandenberg with Falcons. Hey, Eva Rays, what's going on? So It's crazy. I can't wait to start seeing starships at KSC. Yeah. Rev, keep an eye on the turning basin. There were 8 Iridium missions, okay? Well, now that, yeah, well, Thomas, guess what? Now there's 9. But it's on a rideshare mission. But that's still cool to hear. They made a bunch of spares. Whenever you're making a satellite constellation, if you have a set number, so i.e. say your satellite constellation is 20 satellites, build 25, just in case. You never know. Drive past it almost every day. Yeah, I'm not jealous at all. Yeah, I'm not jealous at all. Anyway, let's pop into a little bit more. So this is coming from Fariel again. Ah, there's the top of the tower. And there's the chopsticks. Note that the 39A chopsticks are shorter than the ones at Boca Chica. Man. There's the start of a new high bay in Florida. Yeah, Fariel flew over with Greg. It's interesting since those 6 would have been launched by Relativity per this release from 2020. Yeah, I guess Matt just said, man, never mind. Barely use the chopsticks and they're already improving. Yeah, crazy. That's Hangar X right there. That's a Falcon 9 refurbishment facility. This is basically where Falcon 9s are stored when they're not using them. They recently expanded it. Basically from here over is all brand new. I'm not exactly sure what this part is for over here. I'm going to guess fairing processing because they have a fairing truck out in front with a trailer that's designed to hold, well, a fairing. So that I'm just putting it out there. That probably is it. And then over here is probably a storage facility and warehouse for any refurbishment parts. If I had to guess, that's just a huge guess. That was a guess, but it seemed logical. Anyway, we'll wait on the next NSF flyby video to see. But, oh. Helicopter. Helicopter. Wait a minute. Yeah, I have a buddy who works there on fairings. Oh! Sweet. Well, I guess I was right. Sweet. That was just a guess, man. Fellas, I actually noticed something. Hold on, let's go right here. I noticed something interesting we didn't see before. Huh. Interesting. Yeah, that's pretty interesting right there. No, they put down a bunch of slabs that are kind of in groups of 4. You see that? So why should you care? Okay, great. It's a bunch of concrete in the ground, EJ. Thanks. So if you go over and look at the other side of this build site, they used the 4 slabs to build the catch towers. Interesting. Stage 0 mass production. I can't prove it, Aqualux, but that seems to be the heavy implication here. Interesting. Yeah. You're like, why would they build them over here? They got them over there. What are they going to do? Build multiple of them at once? Maybe we'll see a converted oil rig in the turning basin sometime. Wouldn't that be something? I would also just like to point out the scale of this project. See the truck right there? Yeah. Yeah, this is these are pretty big cranes. Is the turning basin even deep enough for that? I you know what, man? I have no idea. I don't know. I have no idea. But that would be pretty cool to see if it was deep enough, right? The real question is it deep enough for you? All right. So Julia Bergeron had took some flyby pictures as well. Man, that building went up real fast, man. This building was a skeleton, like one row of skeleton a month ago. Now it's almost halfway done. The filter killed anything you just did. Oh, I was singing Deep Enough for You. Deep enough for you. The answer was like a Mustang, redlining every single gear with the chance. Born in 45, but lost his groove back in ancient times. No? Deep enough for you. All right. Also, this retention pond is now retaining very well. Very well. Oh, yeah. How's the rain noise with more ceiling in? I can't even hear it anymore, Beryl. Yeah, can't hear it. It's not only just the drop ceiling, dude. I got insulation. Big, thick boy insulation sitting on top of it. I understood that reference. So cool. Not only do we have Starship static fires, but we got a lot of Starship updates. Pretty sweet bing. Okay. Check this bit of news. We saw that really cool video, that really cool promo video about Dream Chaser. Well, it turns out that may or may not have been timed with a press release. Sierra Space and the United States Department of Defense Transportation Command to develop revolutionary high Mach systems for terrestrial point-to-point delivery with Dream Chaser. Point-to-point cargo delivery with Dream Chaser. Hey, Aqualux, you know what would be really good at doing point-to-point transport? You know what would be really good at that? You know what would be really good at that? Go ahead. Say it. They know. How much cargo can it carry? Not much. Next part of that video is coming in a few weeks. Point to point on that scale seems wildly impractical. 2 Utes. No, X-33 would be really good at this. So let's read. A leading commercial space company at the forefront of creating and building a future for sustainable transportation and infrastructure for low Earth orbit commercialization announced today the signing of a Cooperative Research and Development Agreement, CRADA, with the United States Department of Defense's Transportation Command, U.S. Transcom. It's pretty sweet. Yes. Not sure. If only there was some sort of suborbital hopping system. Okay. The two organizations will work together to develop solutions using Sierra Space's Dream Chaser spaceplanes, Shooting Star cargo modules, and on-orbit infrastructure that provides unique capabilities for precise, cost-effective, and timely global delivery of Department of Defense logistics and personnel. Okay. Both parties will collaboratively explore space transportation as a new mode of point-to-point global terrestrial delivery of material and personnel as an alternative and complement to traditional air, land, and surface modes for Department of Defense global supply chains. Additionally, the agreement outlines plans to identify current capabilities and maturity of Sierra Space's space transportation methods, as well as both observed and projected risk, benefits, and additional research and development needed as a result. What next? Are Navy SEALs gonna do Bud's training moving Dream Chaser around instead of a dinghy raft? It's not called a dinghy raft. It's a rigid inflatable. Yeah. How does EJ know that? Shh. Ain't gonna fit. Space Team 6. Yep. Dinghy rigible. Ding rigible. Yes. I mean, ain't nobody gonna shoot them down. They're going too fast. It's just a feasibility study of essentially. Way too many issues on the launch side to contend with that anytime soon. You think a Falcon 9 booster could send it into transatlantic territory over there? Yeah, of course. Falcon 9 could put it into space, Neuro. Easily. What's the news with Dream Chaser? I like the idea of the one-shot starship. Yeah, me too, Mile, to be honest with you. Can you imagine? You could basically put a SEAL team anywhere in the world in 45 minutes. That'd actually be kind of cool. You could put SEAL, Army Rangers, Air Force test pilot. Not that they would they'd be any use on the ground, but whatever. What a ride that would be. Dude, that would be amazing. I'm not gonna lie to you. That'd be freaking sick. Oh, that would be amazing. Just the booster, not the second stage. I think it could do it, Neuro. Yeah, it could put Dream Chaser on a transatlantic crossing, but you ain't getting your stage back. No, the stage would be going much too fast. 45-minute with the most public perspective ever that it would require require days of launch vehicle setup. Yeah, exactly, Rock Guy. It wouldn't exactly be stealth, would it? Okay, Rocket Guy, new plan. We take a Nimitz, okay? We take a Nimitz, right? And then on the back of the Nimitz, right, where they test jet engines, we, take a bit of sea launch, just put that on the back. It'd be fine. And then we get something like Neutron. That way you can launch anywhere. No one would find it. Big catapult. Yeah, or we could do that. That'd be pretty sweet. Higher tech World War II gliders. Yeah. Isn't it interesting, Floating Disc, that gliders are back on the menu, but they're hypersonic gliders instead? Could take a sub, put guys in missiles. Build a submarine big enough to launch a Dream Chaser with an ICBM first stage behind it. Could be way too heavy. And also, I think people would notice you putting a Dream Chaser inside of a submarine. Makes more sense to use this more as Star Wars, intended with personnel stationed on orbit, and then use Dream Chaser to fly in hypersonic. You know, Rocket Guy, I can't prove it, but I'm 100% sure that somehow violates the Outer Space Treaty. Just want one hypersonic glider in your life. The X-37B already exists, Ivan. This actually makes more sense than a Starship if you put it on top of something reusable. Usually when they need something now, they don't need 100 tons of it, and it's easier. Well, they're not the only ones that Transcom has signed a contract with, Aqualex. They signed a contract with Electron. Or with Rocket Lab for the Neutron rocket. Oh, that's what chat was saying. Neutron first straight. Neutron first stage with Dream Chaser on top of it. Whoa. I meant my boy shuttle. I know what you meant, man. Yeah. Yeah, that's right. It wouldn't fit on it, would I don't know. I don't know. Hey, who's he? I don't know. Anyway. Interesting. No, that's Astra. That rocket doesn't exist anymore, Snibbles. They abandoned it for a different design, believe it or not. Not big enough, I recall correctly. Dream Chaser carries almost the entire Neutron rocket payload in itself internally. Yeah. mean, Rocket Guy, you need something a little bit bigger than that. Something like Antares. All I'll say is that the USAF's Air Force and the Space Force is way better at hypersonics than publicly known. Yeah, Neuro, I don't know why we're so worried about, like, oh my god, everybody has hypersonics, you know, and the way that gets reported is like implying that they have something that we don't. So hypersonic things and hypersonic gliders, those have been a thing for a long time, like a really long time. You guys want to see a hypersonic glider? You guys want to see it? Here, there you go. There's a hypersonic glider right there. Stratolaunch would be better. Yeah, that's a really good hypersonic glider. I like that one. I'm quite fond of that one. Looks old. Yeah, I know. That's the point. That's what I'm trying to tell you. That's what I'm trying to say. Also, X-15. I don't think the X-15 got to hypersonics, Tessa, but I don't know that for sure. You might be right. I don't know. I forget. Chat Lexa. What was the fastest the X-15 ever went? The X-15 spacecraft reached a top speed of Mach 6.7, which is equivalent to roughly 4,200 miles an hour. Thank you. Thanks, Chat Lexa. I'm learning. Yeah, the point is, I mean, Neuro, yeah, you're probably right. It's almost like we've been messing with hypersonic things for, like, over 40 years. Yeah. All right, now play Fortune. Yeah, okay. I can't actually, like, say that, Alex, because, dude, I used to be like, hey, you know, AI person, play this or play this. And I used to say like the actual names, right? And one time I said it out loud, like in the middle of the night, and a viewer was like, dude, did you say something to my Alexa in the middle of the night? And I'm like, yeah. I said it as a joke, and he's like, dude, it woke me up. I got my gun out. I thought somebody was in my house. I'm like, okay, yep, I'm never doing that again. I'm never doing this again. No, pass this part. In fact, never do this part again. I was like, oh, now I feel really bad. He's like, yeah, I woke my girl up and everything. I'm like, oh, now I feel really bad. No, to be fair, the guy was like, no, that's really funny, but you just scared the crap out of me. No, the guy thought it was hilarious, first of all, but I was like, I'm not doing that ever again. I mean, no me gusta Despacito. Despacito es mierda. Ugh. Caca. But it's funny when you do that. Yeah. I'll just ask. Estoy de acuerdo. Acuerdo? You want to go fishing? You want to go fishing? Why? Silencio, Wood. Tranquilo. Tranquilo, amigo. I know what you said, Ivan. I just think it's funny because you want to go fishing? What? What does that have to do with anything? That's awesome, Tessa. That's pretty funny. All right. Anyway, That's cool that Dream. I mean, guys, remember it's a feasibility study with Dream Chaser. Rocket Guy did say this, but it's a feasibility study. So basically a feasibility study is basically the Air Force and Sierra Space going, if we were gonna do this, how would we do it? If we were going to do this, right? Just like in the 80s, it was like, if we were going to make space lasers, how would we do that? How would we go? How would we go? Asking for a friend. Yeah, the feasibility study is the equivalent of, hey guys, my finger's stuck in the toaster. How do I get it out? Asking for a friend. Yeah, hypothetically speaking, it's like, hey friend, hey Sierra Space, it's your friend Air Force and Space Force. Oh, hey Space Force, how are you? Hey, I got a question for you. Like, say you were going to, you know, like, if say you wanted to like launch Dream Chaser, you know, to Vietnam. How would you, if like on a quick flight, like say we wanted to get 5 people, very important people, to Vietnam with Dream Chaser, like really quickly. How would we do that? And Sierra Space goes, you want to do suborbital point to point with Dream Chaser? And then Space Force goes, no, we don't want to do. But seriously though, how would you do that? And then Sierra Space would be like, step into my office, friend. This is how aerospace defense industry conversations go in my head. Corporate people, am I close? Yeah. Full use. Yep. Yep. Do you remember the show Future Dogfights where they had a thing with fighters that could get out of the atmosphere? No, but that's pretty cool. Unfortunately, it's much more boring. Yeah. All right. It's really a 125 slide PowerPoint that could have just been an email. Weather guy, I don't know about you. I hate fluffing stuff up like that. My brain is just, I'm just not smart enough to be able to play that game. You know what I'm saying? I'm really not smart enough to do that. Actually, you know what? That's not even the truth. You know what? Forget I said that. I can do it. It just, like, I die a little inside if I have to speak corporate like that. It just, yeah, I die a little inside. Yeah, just a little bit. No, stop it. It's a matter of learning how to do it. Yeah, you're right. I could do it, Rocket Guy, like really, but you barely managed tic-tac-toe. Shut up. Who's more foolish, the fool or the fool that follows him, fool? Fool. I've been out of the corporate world for over 2 years now, and I still talk like a lawyer. Nice, getting it done. What's that, T-Man? Oh, cool. Nice. A close-up shot of the TSMU enclosure on SLS. Boop. There it is. It's literally some scaffolding with some painter's tarp and some positive pressure. Hell yeah, NASA. Hell yeah. Look, they just got a mobile HVAC unit on caster wheels. Oh, cool. And duct tape. Hell yeah. Hell yeah. That's amazing. Oh, why does that make me happy? Just get some guys out there. Put it around the scaffolding, put positive pressure in there, and duct tape it shut. Fix the damn seal. Hell yeah. Would this be Jacobs doing this? I'm not 100% sure. That's freaking sweet, dude. Oh, that's so cool. It's literally a duct tape. It's literally a duct tape freaking improv clean room. That's amazing. It worked. Yeah, no, it worked. This isn't even Elon tent, dude. Imagine Dream Chaser pulling some crazy combat insertion maneuver. The problem with doing that with a cargo plane is getting it to drop like a stone and then pulling into a landing. Yeah, it could work. It is. Rocket guy with Boeing's hell. Okay, Rev, it's Jacobs with Boeing's help. Yep. That clean room is a single Home Depot trip. I love it. Just get some painter's tarp and some duct tape and then hit it with positive pressure. It's a great way to make a clean room environment. It works. If it's stupid and it works, then it ain't stupid. Oh, man. I just want to, I would love to just stand here. Not when the rocket goes off. Just to stand where those guys are chilling. Just for a second. Now this is going full Elon tent. Yep. I mean, I did stand over there once. Been up that staircase right there, which is pretty cool. With this, don't they need to bring it back to the VAB? NASA's going to try everything they can, Ivan, to not do that. They don't want to. This isn't stupid. It's freaking awesome. Change the seal out. Let's go, baby. Let's do this. Also, look at how big that damn rocket is. The thing's huge. That's how we make all our enclosures. Whatever. It's good. No, they actually decided against it in the presser this morning, Ivan. Yeah. Next launch opportunity. They're targeting the 23rd or the 27th. Either one. Oh, that's so freaking cool, dude. Hey, Rev, can I like next time you go out there, can I just like tag along? I won't make a sound, I swear. I'll just you won't even know I'm there. What's the diameter of the SRB? 3.7 meter. You man, it's the SRB is the same diameter as a Falcon 9, dude. Gonna watch the whole presser, but TLDR, what did I miss on Artemis 1 today? They're gonna fix the seal in place on the pad, and they sent a contingency package to the range to try and get the FTS batteries recertified. But I'd love for you to. Unfortunately, I don't make those choices. Yeah, all right. I would do that, Aqualux. Absolutely. Yep. Okay, fine. We'll have to talk to Joe. We'll have to talk to Joe then. Maybe he knows somebody. Anyway. Gone, AJ, would all be the same. No, Hawks, I would be on full tilt here. This would be full tilt for me. I would just... Dude, like, there are, like, hype levels that your boy gets to. Like, oh, that's pretty cool. Oh, that's really freaking cool. Oh my gosh, that's amazing. My mind is exploding here. So, like, when we saw Starship first flip and burn, we got to my mind is exploding. I cannot comprehend what's going on. And then after that, it's full tilt. It's just, huh. That's pretty neat. Oh, that's cool. It's hanging from the SRBs. Yeah, Ivan, that's right. Can I just look at this picture again? Yeah. Eight hold down points. 4 on each SRB. Yep. The whole thing is hanging off 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, right, Rev? Yeah, dude, I'd just sit here and be like, well, that's a thing. That's a thing that exists. All right. It's crazy. Unbelievable. The freaking TSM is bigger than your college apartment. Yeah, they are pretty large and in charge. I'd love to be there for the first crewed flight, but planning a vacation around a launch is a really dumb thing to do. Scrubs, delays, etc., etc. if you're going to go see a launch and you're going to do it during a vacation when you're in Florida, yes, you do plan around it, Hawks, but I understand what you're saying. You plan around it. And make sure that the rocket scheduled launch date, the net date, is the first day that you're there. Because best case scenario, you get right to Florida and you get to see a rocket launch. Worst case scenario, and actually this is still part of the best case scenario, you get to go to Florida, you get to see a rocket launch, and then you got a week in Florida, you can do whatever. And there's plenty of cool things to do in Florida. Trust me on that one. Second part of that is if it scrubs, you don't need to worry about missing it. And then you get a week in Florida with potentially a day down the road where you got to go, oh, you just got to go back to Kennedy Space Center. Jeez, that sucks. I should clarify, EJ, planning a vacation from Australia to the United States. Yeah, do what I said if you're going to do that. But yeah, that could get expensive for you. Yeah. 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 Also, there's plenty of things to do in Florida. Plenty of things to do. But rockets is at the top of that list. But also, that's pretty sweet. Yep, the 23rd is the tentative date. But dude, look at that monster. Look at that monster. I thought they removed anything that could catch fire. Apparently they didn't mow the grass enough. The fire found a way. Fire! Yeah. Fire! 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 Yeah. Fire! Yeah. Settle down, Beavis. Whoosh. I need the rocket for my launch pad. Yeah. Are you threatening me? Remember how I said I really would like to be more professional on stream? I lied. Yeah. Anyway. You're doing great. Oh, thank you. So, actually, that's pretty cool news. I like NASA's can-do attitude that they have all of a sudden. It really is cool. It's really cool to see them do that stuff again. It does make me happy. Isn't there the American Space Museum there? So, Astro, you have Kennedy Space Center Visitor Complex. And this is just a shameless plug. Anytime you go to Kennedy Space Center Visitor Complex, take the extended tour. Just do it. Thank me later. Remember when they said, Sully, I was going to kill you last? Oh, that's right, Memphis, you did. I lied. Did you do something to your mic? You're peaking it way more. Yeah, 2020, remember? When everyone's like, oh, EJ, the source to all your sound problems is just get a noise gate. Just get a freaking noise gate! That actually didn't go through. Or it did go through. Huh. Sweet. No, it's cutting off because of the noise gate, dude. It's something kind of like RTX voice. And it doesn't like the impressions, believe it or not. It actually cuts it out. Yeah, gatekeeping noise. Imagine doing that. I thought it was your mic vibrating from the desk. No, it's vibrating from these, not desks. They have one of these out there now, but they aren't allowed to enter the area due to there being fuel in Ship 24. What is this? Oh. On a positive side, I love I don't hear your AC anymore. Okay. But also... Oh. That's cool. Brush truck. Brush truck. Brush truck. It's an F550 brush truck. Oh, that's cool. I want it. I want it. I want it. I want it. Yeah, its tires aren't offset. Yeah, it's almost like it's designed to do something and do it well. Remember that, Cirrus? Remember that? When you don't run a lot of tire offset because you actually want to get something done and not look like a complete fool when you're driving down the road? Yeah, funny how that works. Oh, brush truck. Oh, that thing, dude, it's so freaking cool. I love it. I want one. I want one. I want one. I want one. Tires are too small, but Kaiser, it's got tractor tires on it, man, because it's designed to drive over anything. It's got tractor tires on it. It's a truck with tractor tires on it. That's freaking cool, man. Why am I geeking out over this so much? I don't know, but that's really cool. Look, brush truck. Brush truck. Say it with me. Brush truck. What is a brush truck? It's a small off-road firefighting vehicle, Ivan. Yeah. So this is an F550. It's this thing. See the tires look kind of weird, almost like they're tractor tires, because they are. Those are tractor rims. This thing is designed to be able to drive out into a field and put out a brush fire. It's a small fire truck. It's a tiny fire truck. So it's basically like if you took a Humvee and a fire truck and combined them into one vehicle. It's really freaking cool. Got your water tank there. There's a pump on the back with the fire hose, and check this out, dude. It's got a remote fire hose on the front, so you can turn it and spray things from the front bumper. And it's got a winch on it too. But forget just having a winch. No, we need a winch and a fire hose. It's really freaking cool. Yeah, there you go. They're used to put out brush fires. Brush trucks are really cool, man. That's a really cool truck. I want it. I want it. I want it. It's so cool. Because you're a nerd. Yeah. Did you see Everyday Astronaut streaming van? Oh, dude, that thing is so legit, Neuro. It's visible in the lower right, waiting to enter. How'd you get pictures of it, Tom? You know what? I don't want to know. You're going to make one. You have a shop now? Dude, I would... Where is it? Oh, it's right at the front. Brush truck. Right at the front. There it is. Brush truck. Panta. An F550 4x4 Wildland. You found one? You found one? Oh no. Oh no. Oh, that is tits. I want it. I want it, and I want to. That's what we would make into a streaming vehicle. I've decided that thing. Oh, it's so cool. Why am I geeking out over a truck? Because it's a truck and it's really cool. Brush truck. How about we just find an F550, right? We find an F550. We give it the brush truck tires so we can drive anywhere. And then we put like a shell on the back. Gov Planet? Don't mention Gov Planet on here, Weed. Don't do this to me. Why am I doing this? This is such a mistake. Oh, gosh. Okay. Uh-oh. I love this site. Dude, this site is bad. This site's bad news. This site is bad news. You gotta help me. You gotta help me. You just gotta hide me somewhere. You just gotta hide a flatbed for 2,500. Uh-oh. And it's a manual. Chat, it's a manual. Yeah, I know, Neuro. Yeah, yeah. Stop it. Get some help. Oh, yeah. Oh, yeah. Oh, yeah, bud. Actually, these F550 utilities are not... Look at, there's a ton of them on here. Dude, and you even got windows on that. This would actually make a pretty good little streaming truck. You can use it to move Fred. Yeah. It's not funny. Or you get the cherry picker. You get the cherry picker and you just put a camera up on the end instead. That would be bad. That would be bad news. Quad cab. Quad cab. Quad cab utility for $1,500. Oh, this is bad. This is the chat. This is not good. You can turn the flatbed into a pallet. Oh, stop. Box truck. Why are there so many F550s just chilling? Oh no. Oh no. Oh, it doesn't have a motor in it. Okay. What's that, Penta? Oh. Oh. Uh-oh. Yeah, Hawks. Dude, it's... Oh, no. Dude, what did you find? Wait, what the hell is this? Wait, it's in Queensland. Oh God, oh God. It's $275,000 redos. Hawks, hell no. What? Wait, why? How did this get to Brisbane? How is that even a thing? How is it on GovPlanet? Now that would be a streaming truck. The Snap-on tool truck. Yeah, you see now? Yeah. That's a lot of dollar redos, man. $3126 Caterpillar. Dude, this like a utility truck like that would be sweet. You're more partial to the Ranger. Yeah, but these things, this F550 could rip a Ranger in half. Oh, that's no good. That's no good. I'm telling you, we'll do it one of these days. We'll do it one of these days. Actually, hold on. Hold on. Hold on. EJ has a dumb idea. Don't do this to me. Don't do this. Don't do this to me. This. Uh-oh. That's... Oh, man. Freightliner MT-45. Oh, that's got a Cummins in it. This is not good. This is not good. This was my idea.
Discovery, go at throttle up.
Is there a utility Humvee around with like the medical tent on the back, the meat wagon Humvee? Where is it? Where's the meat wagon? Any meat wagons? I'm not looking anymore. No, yeah, no, it's no good. Hey, Everest, 19-month resub. No, no meat wagons. Oh, there is one more thing. There is one more thing. My buddy Tim found this the other day. It's out of my price range. It's out of my price range, but So the cool thing about this, guys, look at its location. Look at its location. Edwards, what happened? Nah, that's just a Chevy S10, Edmana. So, look at the side of this thing again. It doesn't like the new tab thing. That's a NASA logo. This RV was actually used by NASA. It was used at Dryden Flight Research Center. I'm not exactly sure what it was for, but it's definitely ex-NASA. See? It's a NASA Airstream. Yeah. Airstream Executive Air Coach. I want it. Shuttle recovery? It's possible. Any of Hoonigan's vehicles for sale? Well, I tried that. I tried that already. Yeah, that's pretty dope. I don't see any meat wagon Humvees around either. How much? 10 G's. Someone sent me to the bad place again. What happened to that one? Actually, you know what? Let's search by highest price. The meat wagon ones are probably... Jesus, you can get a Humvee for $4,000 in great condition. See, I'm looking for something like this, but the meat wagon variant. So this one is the canvas top, but it's a single cab Humvee. Scanning. Well, it runs. That's good. See, it has that big canvas top. There's one that has a hard top cover like that they use for medevac. The Army uses it for medevac. I forget what the number is. See last. Check what's in the back of this. Oh no. Oh no. Oh no. Is that an IDI diesel? Very nice. It runs. It is an IDI. Okay, there's another video coming here. Let's go over there. Let's just go around the video. Where's the back? What the hell? That's a machine shop. It's got a crane. It's got a gantry crane in it and a workbench with a wireline pressure control van. I'm not familiar with these. Yeah, there's a hydraulic accumulator. I'm familiar with those. There's your hydraulic reservoir. And there's your filters. And there's your valve. And there's your... Oh, boy. Oh, boy. That's a little auto shop built into the back of that thing. It's designed for fitting hydraulics, but... That's really cool. Yeah, GovPlanet is trouble. GovPlanet is very, very big trouble. Anyway. Oh no. Oh no. Oh no. I found something else that I want. The trailer section. The trailer section. I gotta stop. I gotta stop. Is it trouble or is it content? I can't do this, man. I can't keep looking. I wanna buy all this stuff, man. That's no good. Ferd. Sort by Ferd. Oh. A tree spade truck. Look at that thing. Oh, that's cool, man. You can dig out trees and move them. Look at the freaking spade on the back. That's badass, man. I want it. I want it. And it's so bad. It's so bad. Man, this is not good. This is not good for me. This is not good. I don't want this, but I can't I can't stop. Short bus streaming band. You're an auto junkie. Jaywa, I have a carcane addiction. I have a bad carcane addiction. Or truck cane, I suppose. Don't look up Bridgeport Mills. Oh, I've done it before, Signer. Don't you worry. Yeah. Or we could just go with the original plan and just build Tough Enough into that. But I like... Tough Enough's a great work truck, so I don't know. Sawyer, are you here? Hurricane addiction is God's way of telling you have too much money. Yeah, but wait, I don't have money. I spent it all on a house. Extended cab F600 or F800. Extended cab F800, dude. Oh, that's not good. That's not good. It's an extended cab F800. Those are super rare. They're super rare. They're really cool, though. I want one. I want one. You could have had the Snap-on truck for much cheaper. What is this? Hold on. Super Duty custom service. What's in the back of this thing? Dude, it's got a freaking box on the back. Look at that thing. What would make the best streaming vehicle? I think these 550s with the utility box on them would be more than enough. But the thing is, guys, you know what I would do? I wouldn't make like one single dedicated streaming area. I would make it a control room, but it wouldn't be the relay for the internet. I would have live views, and the live views would be piping to a virtual server, and then that would be the place that you can control the virtual server from. So it's kind of like halfway between what Timmy is doing and halfway between what Das is doing. Bro, I found it. What did you find? It is part of the shuttle servicing crew. Oh my goodness. Oh my goodness. I want the 79 or the 1978 stair truck. I'm not going to lie to you. I've always wondered what happened to those F-250s. Come on now. Oh, I wish. 6x6 camper. Dude, it's there. There it is. It's right there. That's the truck. Oh, man. Wouldn't that be cool? Wouldn't that be something? I need more money, man. Gotta figure out a way to make more cash. Buy it and you'll clean it. Oh, no, how am I gonna get that home? Don't tell her, just press the buy button. I don't have the money. You could maybe go halfsies. Prima would kill me. She'd kill me or not. She'd kill me. She'd kill me. She would kill me. I did that, like, that would piss her off a lot. You can propose again, right? Not with a wife, Tessa. Yeah, but it would be content. Flip trucks. That's what I want to do. I want to flip vehicles, guys. Just on a side note. That would be a really good side hustle for the stream. And it also makes content for said stream, which is why I've been focusing on getting the shop up and running. How am I gonna get an Airstream executive motorhome back to Massachusetts? How are we gonna do that? I mean, people are gonna say drive it, but how are we gonna do that? How did Magnuson do? Podium, Mab. Third place. Third and ninth, I think. $10,000 write-off. There's a thing about writing stuff off. You can't write off stuff that you can't write off money that you don't have. I don't know, Hellfish, but I know people with a dealer plate. Speaking of shop, Hasterblan, yep. Was that from SDS1 recovery? It looks like it was a shuttle support vehicle, Nero, for those were hydrazine purging vehicles that we saw in the video. Gotta spend money to make money. Dude, I wouldn't even know how to work on this thing, to be honest with you. Yeah, Ryan, it's good. It's got 8,000 miles on it. How much would that thing cost new? You don't want to know. It's got, hey, there's even a fridge.
Discovery, go at throttle up.
Yeah. That's an actual NASA vehicle. It's literally at Edwards Air Force Base. Yeah, it's at NASA Armstrong. That's NASA Armstrong right there. What the hell am I gonna do with that thing? Does it run? Hold on. Let me check the description. Does the thing run? I was gonna say it would be a bad idea to buy it, but that fridge makes it worth it. Ads, Kickstarter, merch. I know. I'm trying to find details on it. Does it say any details on it? It just... Repairs are limited. Repairs are including, but not limited to, tag axle and new tires. That means it runs. Oh, okay, Creation. It's been sitting. The tires are dry rotted. I can tell from the pictures, dude. This would make the illest streaming setup, dude. Seriously. That's nice, Christian. Cool. I mean, that's cool, but that's not... I don't like talking about that here now, you know? Liam's, hi, so I'm studying chem, physics, and math right now as pre-education for engineering later on, but how do you study physics since I know you know a lot about rockets and how they work? Also, it's based off math questions. How do you study physics? Liam, did they not give you a textbook? Luna who? Oh, Zixie, don't do this. How do we get that? How do we get it? I don't know. Dude, I don't think I'm smart enough to be able to poop out 10 G's, buy that thing, and then figure out a way to get it home in the next 3 days. I know, Focus. Sorry, just excited. Man, that's good, man. No, it's good. It's good.
Discovery, go at throttle up.
Yeah, but to understand it, go on YouTube. YouTube. Pick the concept that you want to learn. Go on YouTube. I'm sure there's a video of it somewhere. It says so in the description. Can't drive it out. Not emissions compliant, not legal to run in California. Not my problem. It's the end of that sentence. I'm not sure I'm smart enough to do that, but I'll get back to you. We'll talk about this tomorrow. Does Ernock have access to a flatbed trailer? Such a cool piece of history. Quick drive Tough Enough there with a trailer. I don't think Tough Enough can pull that. Anyway. Alright, guys. I started a little bit early today, so I'm gonna... What are you looking for? Jam, on Gov Auctions, there's one of NASA's shuttle servicing vehicles from Edwards Air Force Base. Here, hold on. I'll just show you. Here, I'll just link it in chat. If I can't get it, maybe somebody here can get it. I'll link up the auction. If you buy it, let me know, okay? You need it towed? I need it bought. I need to figure out a way to buy the damn thing. Jam, you want to buy it and hold on to it for a little while? I'll pay you back. I'm serious, actually. You could buy that right now if you wanted to. I'll pay you back. No, I don't know how we would... I don't think we can get the logistics done in time, but it would be really freaking cool to do something like that. Dude, look at that thing. Look at that freaking thing. Man. 3 days for what? That. Thomas, I don't know how to... dude, I'm not smart enough to get this done. Yeah. You gotta restore it? Yeah, with the other freaking cars that I already have. Alright, guys. I started a little bit early. We've done about 9.5 hours today. I'm gonna stop for now. And we'll be back tomorrow. Too bad my truck broke. I could hella tow that. How are you gonna tow it? But Mank, you just got here. No F1 Manager? We already did a race, dude. I did Space News, F1 Manager, Space News today. I started at 11 because of that NASA presser, so go back to the video. I know the location of one of them truck things. It's Edwards Air Force Base. Goalie? Or are you talking about the 78 stair truck? The 78 F-250? With the arm thing. So that's the thing that's on Gov Auctions. And then there's the 78 F-250, the stair trucks. And then there's the hydrazine purging vehicles back here.